In this video, I'm going to look at permutations. Now, counting the number of permutations or arrangements of objects is an application of the multiplication principle. Now, let's take a relatively simple example. Suppose I have 8 runners. Okay, and we're going to have a little race, and we want to classify these the finishes. We're going to award prizes for first, second, and third place. First, second, and third. Okay, and we want to know how many different possible arrangements could we have of winners. Well, if we've got 8 people running, we've got 8 choices for the first place. And since the first place winner can't finish second, we only have 7 people left, and so there's 7 choices here for people who can finish second, and then of course 6 choices for the third place finisher. So the total number of choices is going to be 8 times 7 times 6, which you can multiply out and see is going to be total of 336. I don't really care about what the number is. Okay, but now, so we saw how that worked. That was just an application of the multiplication principle there. But supposing we had bigger numbers. Supposing we had like 52 cards, and we wanted to lay down 13. And we wanted to figure out how many possible arrangements could be laid down. Well, I certainly don't want to have to multiply 52 times 51 times, well, I'd have to do this 13 times. Okay, that's going to be a really awkward to come up and try to write down. So what we need to do is to find some kind of better terminology or notation that we can use so we can calculate these numbers in a little easier fashion. Now, that brings us to the idea of factorial. So in fact, a number factorial is used, you say in factorial, begin with an exclamation point after it. Now, and this is just going to be this kind of pattern that we saw here, but completed. So this is going to be the result of taking n times n minus 1 times n minus 2. Well, you get the idea of the pattern. You continue it on down to get to 2 times 1. So, for example, 3 factorial is pretty easy. That's 3 times 2 times 1, which is 6. Okay, 4 factorial. That's going to be 4 times, well, you see, it's going to be 3 times 2 times 1, but we already know that that could be written as 3 factorial, so I could even write 4 factorial in a little more succinct notation. I could go ahead and see this is 4 times 6, which is 24. Or let's do one more here. Let's do it 5 factorial. Well, that's going to be 5 times 4 times 3 times 2 times 1, etc. But all of that repeated diminishing numbers starting with 4 could be written as 4 factorial. So I can write 5 factorial is 5 times 4 factorial, and 4 factorial we just saw was 24, so it's 5 times 24. Well, that'll be 120. Well, I don't really want to build up more than this. But let's go back now to our problem where we were looking at this product here and see if we can't write this in a now a little more succinct way. So remember, the product was going to be 8 times 7 times 6. Well, we could make this into something like a factorial by going and finishing it with 5 times 4 times 3 times 2 times 1. Okay, and so that gives us 8 factorial. All right, but the problem is we then multiplied the original number we were after by a whole bunch of stuff. Well, what if I divide it by the same stuff that I multiplied by? So 4 times 3 times 2 times 1. And notice that still has the form of a factorial. So if I divided this by 5 factorial, then notice what we've come up with. I mean, this stuff just cancels out. So our product, 8 times 7 times 6, could just be written as 8 factorial divided by 5 factorial. Well, where did I get the 5 here? The 5 is just 8 minus 3. Okay, so I could go, if I wanted to make up a formula here, I could say, so let's make up a formula for calculating the number of possible arrangements of R of n distinct objects. Well, let's see, we need a name for that. Typically, these are called permutations. And so this would P of nr, right? Or if you're using calculators, they would write it something like this, npr. And how did we see that could be calculated? Well, the numerator is going to be n factorial, and the denominator is going to be n minus r factorial. So you see, if I apply that to this case here, the numerator was going to be 8 factorial, and the denominator would be 8 minus 3, or 5 factorial. Now, we can calculate these things using a calculator. So let's go off and get a calculator here. All right. Now, let's see what we do here. We can go to math, and it's listed under probability, which you can go to by going to the left one item. And then there it is, number 2, NPR. So we can select that. And, well, unfortunately, I forgot. Let's clear out. The way we have to start this, we have to put in our first number first. We put 8 in. Then we can go to the math, over, down to 2. Now we put in our value 3 and tell it OK, and there's that number calculated for us. Well, in the next video, I'll discuss combinations.